By the mid-1970s, NASA engineers were working against a rigid mathematical deadline. They had a launch window closing in the summer of 1977, and missing it meant losing a rare celestial opportunity. The mechanics of the solar system were offering a brief geographic alignment. Jupiter, Saturn, Uranus, and Neptune were drifting into a perfect simultaneous curve along the same side of the Sun. This alignment enabled a gravity assist. Diving into a planet's gravity well steals orbital momentum, flinging the probe outward. Stringing these together creates a chain reaction, bouncing from Jupiter to Saturn, Uranus, and Neptune, completing a grand tour in a fraction of the usual time. But the planets arrange themselves in this exact sequence only once every 175 years. The engineering teams had one shot to build, test, and launch their explorers, or the geometry of the solar system would lock them out for almost 2 centuries. They made the deadline. Voyager 2 lifted off in August of 1977, followed 2 weeks later by Voyager 1. The massive kinetic energy of the launch vehicles punched them through the Earth's atmosphere. Underneath the fairings was a delicate, spindly machine. The craft was dominated by a large, white parabolic antenna for calling home, with exposed, fragile sensors hanging off its metallic struts. Both probes were immediately pushed to extreme speeds, exceeding 60,000 kilometers per hour. Because it followed a more direct trajectory, Voyager 1 actually overtook its twin sister in deep space just months after leaving Earth. Launching these delicate arrays of 1970s circuitry into the freezing vacuum was a profound technical gamble. They were fragile, human-made avatars, operating at the absolute edge of what was then possible. The gamble paid off rapidly. By March of 1979, Voyager 1 arrived at Jupiter, returning incredibly detailed portraits of its turbulent Great Red Spot. In November of 1980, it swept past Saturn, revealing the stunning, intricate structures of its rings against the absolute black of space. Voyager 2 then carried the torch outward, executing close flybys of Uranus in 1986 and Neptune in 1989. To this day, those photographs remain the only close-up looks at that smooth, purple-blue sphere humanity has ever captured. With Neptune receding in the rearview mirror, the grand tour was complete. The bright era of planetary exploration ended, and the long, lonely drift into the dark began. Having successfully stolen momentum from the gas giants, both probes abandoned the planetary plane. They angled outward, hurtling away from the Sun at blistering speeds of up to 17 kilometers per second. They must escape the heliosphere, a magnetic bubble generated by the Sun. Voyager 1 pierced this boundary in 2012, followed by Voyager 2 in 2018. Today, Voyager 1 is over 25.1 billion kilometers from Earth. They are no longer sailing in familiar waters. Both machines are now totally exposed, navigating the true, hostile vacuum of the galactic void. Curious, which raises a practical question. How does a piece of technology built during the Carter administration stay warm and functional in the freezing dark for nearly half a century? This chart maps their power source, a plutonium-238 radioisotope thermoelectric generator. It's an atomic heart, turning radioactive decay into electricity. But this decay is finite, dictating an inescapable, continuous bleed of available power over time, dropping the wattage lower each year. To keep the core systems from freezing, engineers at NASA are forced into desperate power-saving measures. From billions of miles away, they are permanently shutting down scientific instruments one by one. It is a methodical sacrifice. We are slowly blinding and deafening our greatest explorers, cutting off their senses just to keep their faint transmission heartbeats alive for a few more years. The math tells us exactly how this ends. Sometime around 2036, the power reserves will fall below the absolute minimum required. The last instrument will die, and the probes will plunge into permanent radio silence. Yet their operational lifespan of 6 decades is a mere blink compared to the immense timelines of their physical journey ahead. Locked into their outward trajectories, they will simply coast. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the red dwarf star Gliese 445, while Voyager 2 will drift silently past another star, Ross 248. Long after their final signals reach Earth, they will continue outward as completely dead, frozen artifacts hurtling through the dark. Voyager has transitioned from a planetary explorer into a silent ghost ship, a lasting monument to human curiosity, wandering the deep void long after we are gone. Right now, Voyager 1 is more than 25 billion kilometers from Earth. Its nuclear battery, powered by the decay of plutonium-238, is steadily running out of energy. Sometime in the 2030s, NASA will shut down its final scientific instruments to conserve what little power remains, leaving the spacecraft completely dark and silent. Because it is moving incredibly fast through deep space, it's easy to assume Voyager is on its way out of the Milky Way entirely. But the physical reality is far more confining. The probe is trapped deep inside the massive gravitational well of our home galaxy. An object needs to reach roughly 600 kilometers per second to break out of the Milky Way. Voyager is traveling at just 17 kilometers per second. Even adding the galaxy's rotational speed, it lacks the momentum to break free. Caught by that gravity, the probe is locked into an endless path. It will orbit the galactic center forever, completing a single massive lap roughly every 10 to 25 billion years. Voyager is not an escapee breaking out into the wider universe. It is a permanent prisoner, caught inside a living, evolving galaxy. And that galaxy has a violent timeline ahead of it. About 4.5 billion years from now, the Milky Way and the neighboring Andromeda galaxy will be pulled together by their mutual gravity. These two immense structures will smash together in a chaotic merger, defined by swirling gas, severe gravitational disruption, and blinding bursts of new star formation. You might expect a tiny spacecraft to be destroyed in an event this severe, but space is so vast and the distance between individual stars is so immense that an actual physical collision is mathematically unlikely. Voyager will almost certainly drift right through the chaos, completely unharmed. Its trajectory will be knocked off course by the wildly shifting gravity. It will cease to be an explorer of the Milky Way and instead become an involuntary citizen of the newly fused megagalaxy, Milkomeda. The aluminum and titanium hardware of the probe will outlast the cosmic storm, but the exact galactic neighborhood it originally called home will be thoroughly and permanently erased. Back near the center of that lost neighborhood, around the 5 billion year mark, our sun will finally run out of the hydrogen fuel it needs to burn. Without hydrogen to sustain its core pressure, the sun's outer layers will expand wildly. It will bloat into a massive red giant that swallows Mercury and Venus, and ultimately scorches the Earth down to bare rock. As this diagram illustrates, by the 8 to 9 billion year mark, the dying sun will cast off its outer layers entirely. What remains of the star then collapses rapidly inward, forming a tiny, hyper-dense core composed mostly of carbon and oxygen, a white dwarf. Throughout all of this, stars move in completely unpredictable, chaotic patterns. Over billions of years, the entire cosmic map gets scrambled, meaning the stars do not return to their original starting positions. Even if Voyager miraculously completed its massive orbit and drifted back to the exact coordinates where it launched, it wouldn't find our solar system. It would only find a cold, dead cinder. By the time we reach the 10 billion year horizon, the sun is completely burned out. Earth has been ruined by stellar expansion, and humanity has been extinct for eons. The spacecraft is no longer an active tool of exploration. It is a galactic ghost, drifting aimlessly through the quiet, settled expanses of the Milkomeda galaxy. The last physical evidence of humanity is bolted to the battered spacecraft. The golden record is an eternal analog fossil. Encoded in its grooves are the greetings, music, and science of a civilization that once looked at the stars. The probe itself will be heavily worn. 10 billion years of drifting through the absolute zero of the void will leave its casing scratched by microscopic dust, yet perfectly preserved in the freezing vacuum. Voyager carries the distant memory of Earth into eternity. It survives as a silent monument, slowly vanishing into a sea of trillions of indifferent stars.